So I have the function f of x is equal to x between 0 and 2 pi. So this is a 2 pi periodic function. And I calculated its Fourier series representation. And if you do that, you should get f of x is equal to pi plus the sum from k is equal to 1 to infinity of minus 2 over k times sine of kx. So that is the Fourier series representation of that function. So the b sub k's are equal to minus 2 over k, so those are the coefficients in front of the sine of kx. The a sub k's are 0, that's why you have no cosine of x, but simply a sine of kx. And the e sub 0 is equal to 2 pi. And this pi here is simply a sub 0 over 2, so we have 2 pi over 2, and so we have simply pi. Yes, so this is the Fourier series representation of the function f of x is equal to x between 0 and 2 pi, and this is only valid if k is odd. If k is even, we get 0, if I remember well. And that's also why we only have b sub k's, by the way, and no a sub k, except a sub 0, of course, because k is odd, so b sub k's, remember the b sub k's are the odd coefficients, basically, and the a sub k's are the even coefficients, but because k is odd, we have only b sub k's, and a sub 0, of course, yes, but no a sub k's, yes. So my goal in this video will be to evaluate the sum from m is equal to 1 to infinity of minus 1 to the m power over 2m minus 1. That will be my goal. Yes. So the first thing I can do is set k equal to 2m minus 1, because I said k is odd, so I can write it as 2m minus 1, where m is any integer, and so I get that f of x is equal to pi plus the sum from m is equal to 1 to infinity of minus 2 over 2m minus 1 times sine of 2m minus 1 times x. So instead of k here, I have 2m minus 1, and instead of k here, I have 2m minus 1. Now I can set x to be equal to pi over 2, and so I have f of pi over 2 is equal to pi plus the sum from m is equal to 1 to infinity of minus 2 times minus 1 to the m plus 1 power over 2m minus 1. So this minus 1 to the m plus 1 power is simply sine of 2m minus 1 times x. Yes, times pi over 2. So if you plug in pi over 2, you get this minus 1 to the m plus 1 power. Yes. You can try some values of m to convince yourself that this is in fact equal to that this sine of 2m minus 1 times pi over 2 is in fact equal to minus 1 to the m plus 1 power. Yes. And so I have a minus sign here and the m plus 1 here, so I can take this minus sign here in this minus 1 to the m plus 1 power, and so I simply get minus 1 to the m power. Okay, so I have like this minus 1 here, it's minus sign, which can be seen as a minus 1 times minus 1 to the m plus 1 power, and I can simply write that as minus 1 to the m power, okay, because we have minus 1 to the m plus 2 power, that is simply equal to minus 1 to the m power, okay. Yes, and so I have pi plus the sum from m is equal to 1 to infinity of 2 times minus 1 to the m power over 2m minus 1. And now that is equal to pi over 2. Why? Because if you plug in x is equal to pi over 2 inside our f of x, we know that f of x is equal to x, so if you plug in f of pi over 2, you get simply pi over 2, because our function is defined as simply being x. F of x is equal to x, so if you plug in x is equal to pi over 2, I get simply pi over 2. Okay. I hope this makes sense. And yes, so this is equal to pi over 2. Now I can take this pi here on the other side, and I can divide by 2. So you have pi over 2 minus 1, minus pi, sorry, over 2. So this is this 2 here, is equal to the sum from m is equal to 1 to infinity of minus 1 to the m power over 2m minus 1. And so this pi over 2 minus pi over 2, so this pi over 2 minus pi over 2 is equal to minus pi over 4, and so that is the value of the sum from m is equal to 1 to infinity of minus 1 to the m power, m's power over 2m minus 1. So yes, so we evaluated this sum here using the Fourier series representation of the function f of x is equal to x. Yes. And I think that's it. So it's minus pi over 4, the final result.